Hello students, welcome to Achieverr.com. I am Ashutosh Mishra and today we will continue with our topic, and today we will start with Venn diagram. So there was a scientist named as Euler who first gave an idea to represent a set in a pictorial form, that is in a square bracket or a rectangular shape, and with some circles in it. And Venn was the scientist uh, who was the first one to came into and Venn was the first scientist who brought this idea to practice. So what is Venn diagram? Venn diagram is representing a set in pictorial form, like this. So this is a rectangle box which represent the universal set. Universal set is represented by U, and these are the two sets A and set B. So this is how Venn diagram representation of the set. So this will be the intersection part between the two sets, like A intersection B. Okay. So there are a few operations related to set which we will be doing with the help of Venn diagram. So first operation is union of a set. Suppose we have two sets, set A and set B, and we will be doing this with Venn diagram. This is set A and this will be set B. So what is the union of set? Union of set is all the elements included in both A and B. So this whole portion will be the union of the set. This is A union B. And we can also give some examples, like if we have set A which is equal to 1, 2, 3 and a set B 2, 3, 4. So what will be the union of set? A union B will be 1, 2, 3, 4. In set we will represent the reoccurring quantities, like 2 and 3 are occurring twice, so we will represent them just once in a set. So this will be A union B. So what second is intersection of set. We have two quantities A and B, same. Intersection means the common area, the common part, this one which we have discussed earlier. This will be A intersection B, and this is the sign of union U, and this is the sign of intersection. So for example, we will take the same example, like 1, 2, 3 and B is 2, 3, 4. So A intersection B will be 2, 3, just the common part. And suppose if we have more than one set, like we have sets A1, A2, A3 up to AN. So what will be the union of sets? That will be A1 union A2 union A3 up to union AN. This will be the union of all sets. Here also, if we have sets 1 to n, then what will be the intersection? Intersection will be A1 intersection A2 intersection A3 up to AN. The third property is, the third representation is operation in the set is disjoint of a set. Disjoint is when there are two sets, say A and B, and there is no element common in it, that is A and that is B. So there is no element common in it, that means A intersection B is phi. So it is a disjoint. Like for example, if we have A is equal to 1, 2, 3 and B is equal to 4, 5, 6. So what is disjoint? Disjoint of a set is A intersection B, which is equal to phi. The fourth one is difference between two sets. So difference is defined as that set of all those elements which are not included in the first one. Like there are two sets, suppose set A and set B. So difference is the set of all elements of A which are not included in B. Pictorially we can represent in Venn diagram like this. This is set A, this is set B. So this portion, set of all elements of A which are not included in B. So this intersection part will not be included in difference, and this is denoted as A minus B. So for example, if we have set A 1, 2, 3 and set B 2, 3, 4. So A minus B will be only 1. And remember, we call this a singleton set. Singleton set is when there is only one element left. So this will be a singleton set and also a difference of a set. Similarly, if we want to find out difference between B and A, so this will be B minus A. And from our example, B minus A will be only 4. So this will be B minus A. Okay. So the fifth one is symmetric difference between two sets. So in symmetric difference, it is same as the difference between two sets, but in symmetric difference, we just eliminate the common part, that is the common elements of the set. Like if we have two sets A and B, so we will eliminate just the common part. So this portion, all this portion will be included, just we will not include the intersection part. And it is represented by something like this: A triangle B. So this is the representation of symmetric difference. So for example, we have two sets, A which is 1, 2, 3 and B which is 2, 3, 4. So A symmetric difference of B will be A minus B union B minus A. So what is A minus B? A minus B will be 1. And what is B minus A? B minus A will be 4. So A symmetric difference of B will be 1, 4. So the next operation is complement of a set. So complement means the universal set minus, suppose we have set A, so universal set minus set A. For example, we have a set A and it is represented by A complement, either by dash or we can write a C just above the A. So this is the representation. And we have set A and this is the universal set. So the complement will be whole portion just exclude the A, set A. So this is complement of set. So there are a few examples. Suppose we have a universal set U which includes all the numbers. This includes all the numbers, every number like natural number, whole number, integers, real number, all real number, everything. So what will be the complement of U? U complement will be 5. Okay. Now there are a few more operations, like we have a set A and we want a union of set A with its complement. So what will be it? It will be a universal set. We can prove this by using our Venn diagram. Like we have set A, this is set A and this will be the complement of set A. So what will be the union of A and complement of A? It will be this whole portion. So A will also be included in this. So A union A complement, that will be universal set. Okay. And what will be the intersection of A and A complement? That will be 5. We can prove this by, this is A, this is A complement, and intersection is, you know what is intersection? Intersection is just the common portion between the two sets. So what is common in A and A complement? There is nothing common in it. So what will be the intersection? Intersection will be 5. So A intersection A bar will be 5. So now we have some laws associated with the sets. These are called laws of algebra of sets. So the first law is idempotent law. Sorry, I'll use the blue pen. So in idempotent law we have two sub-laws associated with it. That is, the first one is A union A, it will always be A, and second one is A intersection A will also be A. So we can prove this by Venn diagram only. Suppose we have a set A, and you want a union of A. So what will be the A union A? It will be same, set A only. And similarly we can prove this A intersection A. So there is nothing more in it, you can do it in your home only. So what is second? The second law is identity law. Identity law is defined as a union of A with phi is always equal to A, and intersection of A with universal set will always be equal to A. So how we can prove this? I will prove the intersection with the union. You can prove the phi with your own. So suppose we have A and we have union. So what is union? Union is this whole. So A is also included in it. So what is A intersection union? It will be equal to A because this is the common portion, this and this. So the third one is commutative law. Commutative law is defined as, there can be two cases in this also. A union B is equal to B union A. We can prove this by Venn diagram. Suppose we have set A and set B. This is A, this is B. So what is this one is A. This one is B. And this one is A union B, which will be equal to B union A. So this is A union B and this is B union A. Similarly, there is second law, commutative law, that is A intersection B is equal to B intersection A. So we have two sets, suppose A, B, so this one is A, this one is B. So what is A intersection B? This is A intersection B. This will be equal to B intersection A. And this is because the same area is common in both the cases, this one. So now we have fourth law, that is associative law. And the first case in this associative law is A union B union C is equal to A union B union C. So this can be proved by Venn diagram only. So suppose we have to make three sets in our Venn diagram. So this one is first, this one is second, this one is third. So first we will make A union B. What is A union B? This whole portion. This is A union B. Then we will make A union B union C. So this one was A union B and we have to include the C part in it. So this will be A union B union C. Now we have to make B union C. So what is B union C? This part. And now we have to add A in it. So this whole portion will be included. So we can see that A union B union C is equal to A union B union C. Now the second one is A intersection B intersection C is equal to A intersection B intersection C. So we can also prove this. I will not draw the whole diagram again and again. I'll just draw the final diagram. So what is A intersection B intersection C? You can do it in your home by yourself. So this will be the final output, A intersection B intersection C. Try doing it at your home. If you won't be able to do, then you can ask. Now the next one is distributive law. So what is distributive law? This will include the intersection and union part at the same time. A union B intersection C, this is equal to A union B intersection A union C. So we can prove this by Venn diagram. So suppose we have three sets A, B and C, and we will first go with B intersection C. So what is B intersection C? This part. This is B intersection C. And now we will add A into it. So A union B intersection C. So it will include this part, this part, this part, and whole of A. This is LHS. Now let's go to RHS. We will first draw A union B. What is A union B? It will include this whole part. This is A union B. What is A union C? it will include this part. So we have to take intersection of these two, that is A union B intersection A union C. So what is the common in both? The common part is A, so this whole, and this part in both the cases. And we can see that this and this are equal, hence proved. So the second part in this is A intersection B union C, that will be equal to A intersection B union A intersection C. You can prove this by Venn diagram. So let's go with LHS. So first we'll go with B union C. What is B union C? It will include this whole part. And what is A intersection B union C? So this is A, and what is the common in both these? This will be the common part. So this is the A intersection B union C. Now let's move on to the RHS. We'll go with A intersection B. What is A intersection B? This one. Now we'll go with A intersection C. What is A intersection C? This one. And what is A intersection B union A intersection C? So it will include both the parts. That is this one and this one. So this is A intersection B union A intersection C, hence proved. So next law is De Morgan's law, and last one. The first one in this De Morgan's law is A union B complement. This is equal to A complement intersection B complement, and we can prove this by Venn diagram again. So first we'll go with LHS side. What is A union B? Suppose we have two sets A and B. So A union B will be this one. And what is A union B complement? So what is A union B complement? It is this part. Okay. So RHS will be A complement. What is A complement? This is A, this is B. What is A complement? A complement will include everything that is not in A. So this one, this portion is included in B and not in A. So this will also be included in A complement. What is B complement? Similarly, B complement will also include everything that is not there in B. So this one, it will include the part of A which is not there in B. So this part is in B, so we will not include it. That is B complement. And what is A complement intersection B complement? The portion which is common in the above two figures which we have discussed just. What is common? This whole part. And you can verify this, that the LHS and RHS are equal. Hence A union B complement is equal to A complement intersection B complement. Hence proved. The second part in this law is A intersection B complement is equal to A complement union B complement. You can prove this by Venn's diagram, and this we will go further with Venn diagram. For example, we have two sets, suppose A and B, and this is union set. So what is A intersection B? This one. This part is A intersection B. So what will be A intersection B complement? So this whole part will be included. The portion which is not the common between A and B will also be included in this. So this is A intersection B, and this is A intersection B complement. So this one was our LHS. RHS will be, first we'll go with A complement. What is A complement? Everything which is not included in A. So this will be A complement. Now we will go with B complement. So what is B complement? Everything which is not included in B. This is B complement. So what is A complement union B complement? So everything which is included in the above two figures. So that is, this common portion is not included only, and rest of the things are included. So this is A complement union B complement, and we can verify that here also this common portion is not included. So LHS is equal to RHS, as proved. So that's all for today. From your NCERT book or any other book, you can do some questions, and you can prove those questions with the help of Venn diagrams. And if you have any doubts, please mention your doubts with achieverr.com. I'll rectify them. Thank you.